Hi, I want to try and make an arc transmitter. I think it's the first ever RF radio wireless transmitter ever invented. You know, back when Tesla was busy wasting his time trying to transmit power wirelessly around the world, other people figured out they could use the same technology to transmit information. Which is literally the same thing as transmitting power around the world. Just that it wasn't enough to power anything, but was just enough to transmit information. There. See, I made the taser a while back and I'm gonna use it to create the arcs I need. And there it is. Let's see if it works after all these years. What happened? There used to be two nails in there and the gap was shorter. Maybe if I put a piece of wire there to make the gap shorter, it starts going. Yes, there it is. Now it works. Died again. What's going on there? Something. Ow, shit! Stupid little shit. Aha! See, this is the circuit I designed for my taser, which I explained in my website electroboom.com if you're interested. I have a relay here that switches back and forth, and when it's on this side, it charges the primary of the transformer. But when it disconnects, there is high voltage energy here that arcs between the contacts, and they heat up and eventually get welded and permanently shorted. And when I flick the relay, they disconnect and start working again. Hopefully I won't have to deal with that problem now. Now I have some general knowledge on how this transmitter should work, and this might or might not be good enough for my transmitter. Well, let's give it a try. This is a typical arc-driven Tesla coil circuit designed by Nikola Tesla. What it does is that using an initial transformer, it amplifies some AC voltage to 10, 20 or 30 kilovolts. This is a spark gap, and at the peak of the AC voltage, when the voltage across these 2 points is maximum, an arc is created between them. And you know, an arc has a very low resistance, so this thing is like a switch that closes at high voltage. Now when the switch closes, the high voltage energy of the capacitor pours into the primary inductor of the Tesla coil, and they resonate and oscillate at a certain frequency which matches the resonance frequency of the secondary of Tesla coil. The huge winding turn ratio of the Tesla coil combined to the resonance frequency can create millions of volts at the output. Now if you're smart enough but not too smart yet, you might ask, when this switch is closed, we still have this inductor parallel to that circuit. How come it doesn't affect the resonance frequency? The reason is that this inductance is much larger than that one, and at the resonance frequency, which is much larger than the input frequency, this guy is like an open circuit. Now while Nikola Tesla was kicking himself with this circuit, other people figured out that we don't need this secondary part. We can just add an antenna here, and this circuit was strong enough to create electromagnetic waves and radio frequencies that could be picked up by a receiver on the other side. Or at least that's what I think. And I'm thinking maybe I can use my taser circuit instead of this transformer to create high voltage here. So the idea here is to transmit radio frequencies to be picked up by another circuit, which is essentially another inductor and capacitor with a resonance frequency that matches the transmitter. And the voltage buildup here would be large enough to be detected by another circuit. So I guess anyone with the proper inductor and capacitor could read your information. I guess we are talking about old times. Nobody knew how to do it, unlike now that I'm telling you how to do it. That's why we need ExpressVPN, the sponsor of this video. ExpressVPN is a simple and powerful app that runs on pretty much any platform, turns on with a click of a button, and secures your network communications, especially on public networks. Data protection, hiding your location, content unblockation. Just visit expressvpn.com/electroboom to get 3 months free service and learn more. Anyway, looking at this, it's very much the same as the original Tesla coil, with the primary resonating with the secondary and creating a voltage there, except that in the Tesla coil these two are much closer and the output voltage is much higher, and as you move this further the voltage goes lower and lower, That's why Nikola Tesla's work was essential in wireless communication. There are different configurations of the same circuit that do the same thing, but for now I'll go with this one and see what happens. I'll have to make my components and my capacitors have to be very high voltage. On my receiver though, the voltage is much lower, so I can use regular components. So for my capacitor, I'm thinking to use my Leyden jar I made a while back. Should clean it up a little bit, but it should be able to handle tens of kilovolts. Does it smell? Oh jeez, it's all rotted in there. Oh, why did I forget to remove the water from there? My screw there turned into powder. Look at this. Yeah. There we go. A fresh screw and wire, and with fresh salt water. So we are ready to go. I don't need the ball on the top. And if it's like last time, the capacitance should be around, 1.3 nanofarads. Okay, so my capacitor is in good shape. Now I need to make an inductor. I'm thinking to make it resonate at 1 megahertz. And for that, I have to do it on paper. F is equal... There we go. I need around 19 microhenry of inductance. Now to make my inductor, I need a big cylinder to wind the wires around. Let's assume for now I'm going to use this PVC pipe with a diameter of 60 millimeters. Now I want to make an air core inductor like this with windings separated by some distance, because the voltage across the inductance I have is like tens of kilovolts, so it could arc between the windings if they are too close. I'm going to use this calculator because their model seems to match what I'm trying to do, and if I put my parameters in 30 turns and half a centimeter spacing between the wires, my inductor will end up being around 18 microhenries, which is close enough. Damn it, I only have enough wire for 15 turns. Hopefully that's enough, otherwise I'll have to add. According to the calculator, with 15 turns, I should get around 7.8 microhenries. That would significantly raise my resonance frequency. Let's measure the actual value. Let's see, how much is the inductance? The hell? It's 0 after all this? I think this is not accurate for the small inductance. I have to do it another way. I measure the inductor like this. I put a 100 ohm series resistor with the inductor, provide a sine wave input and measure the output. Now if I plot the output on a logarithmic scale versus frequency, at low frequency the inductor is like a short circuit, so the output is low, and as the frequency rises, the impedance rises and so the output voltage, until at some point the inductor is like an open circuit and the line goes flat. Now at a certain frequency, the output to input difference is 3 decibels, or the output voltage to input ratio is around 0.7. If we measure that frequency, using this equation we can calculate the inductance. Here, yellow is the input sine wave and green is the output voltage across the inductor. And if I sweep the frequency higher, you see that the green voltage across the output rises too. And when it reaches around 70% of the input voltage, that's where your 3 dB frequency is. But fortunately for me, my scope has this frequency response analysis function that will plot these graphs for me automatically. And here the blue curve is my amplitude change, and I can see that around here is my 3 dB drop, and it is at 1.68 megahertz. And that means my inductor is around 9.5 microhenries. It's in the ballpark. And if I use these numbers to calculate my resonance frequency, it's around 1.4 megahertz. I guess it's okay. Let's actually measure it. When I have a LC circuit like this and measure the output, at low frequency, the inductor is like a short circuit and the output is low. At high frequency, the capacitor is like a short circuit and the output is low. So when I raise the frequency, the output goes up and then goes down again. And this spot, which is my resonance frequency, is where the impedance of these two is infinite and the output is equal to input. Well, my wires here probably will add some inductance to the system and drop the frequency a little bit, but yeah. Here we are, we have a terrible looking peak and the amplitude starts rising at higher frequency again. And the peak frequency is around 1.4 megahertz. See, here's the problem we have when we measure the output voltage at this point, and we have alligator clips here that have some tiny inductance associated with them. At low frequency, this inductance is like a short circuit, and as the frequency rises, the voltage rises until we reach the resonance frequency, after which this capacitor takes over and the voltage drops again. But above some frequency, these tiny inductors become much larger impedance and isolate the capacitor from the measurement point, and the voltage rises again. But if we measure as close as possible to the capacitor to reduce the line inductance, then we will push this voltage return thing to much higher frequencies, which doesn't affect what we are trying to do, just that our resonance circuit will have a little bit of higher inductance due to these wires. Let's try the same thing with the Leyden jar. There we go, now my peak is around 1.5 megahertz and my high frequency inductive crap happens at much higher frequency. If we run our wires straight compared to looping them a couple of times, it will make a significant difference in our resonance frequency, which we could use. Let's put them together. First off, the capacitor. This is the arcs without the capacitor. And now here we have the arcs with the capacitor connected. See, it doesn't arc anymore because I think the capacitor is loading the output voltage and reducing it. So I have to bring the contacts further close. Ow! Shit! Ow! Never rely on the wire coating. Very high voltage easily breaks through it. Here, I made a sophisticated spark gap here that's adjustable too. Now this is with the capacitor across the output. The arcs are much stronger, and without the capacitor, see, it's much weaker. The reason is the capacitor stores a much greater energy and releases it in a stronger oomph. And now I add my inductor to the circuit too, so now the arc has to go through the inductor, and the arcs are a little bit weaker now because the inductor limits the spike of current and resonates with the capacitor. Goody, now I have a loop on my probe and let's see what we'll pick up on the scope. Look at this beauty. It's clearly resonating at a frequency of around 1.4 megahertz with a peak of 5 volts. Let's make a receiver. So here I made an inductor that's around 14 microhenries parallel with a 1 nanofarad capacitor to give me a resonance of around 1.4 megahertz. And this is what we get on the receiver. These voltages are above 40 volts. And closer is larger and further is smaller. The power of resonance. I should be able to turn on some LEDs with this. Here I put 2 parallel reverse LEDs across the circuit, and they barely turn on even very close to the inductor, which means that the received energy is very small, and as soon as we load it, the voltage significantly drops. Which means as long as we don't load the circuit, it should have high enough voltage to detect. So I'm going to use this circuit I made a while back that detects AC voltages from the wire. There we go, and I'm running it off a 9 volt battery, so it's a little bit more sensitive. And if I press the switch there, you see? It's turning on and it's getting brighter when I get closer, and it goes dimmer as I move away. Of course, I didn't put an antenna on these, so I should do that. In AM radio frequencies where I'm at, it greatly helps if we ground the transmitter and receiver and have one of those massive antennas you have probably seen around the roads, at least at the transmitter. The radio waves, like a mirror, bounce off Earth and ionosphere, which is a charged layer in the atmosphere and can travel long distances. I have an extension cord I'll connect to my transmitter as the antenna and another extension cord as the receiver antenna. I guess I'll just connect it to my ceiling light, and I connect the other side to Earth through my scope ground. Well, let's just move it all the way back in this corner, and I'll use the outlet Earth to connect it to ground. There you go, no antenna connected. Don't see anything. Now I'll just hook my receiver antenna to this corner here, and here it is with the antenna. Oh, there you go. Now I can see it much brighter. Of course, at the receiver, the signal will be very small over long distances, so you need a very sharp filter to extract your signal from noise and a very low noise amplifier to increase the signal to a usable level. Well, it's always encouraging to know your knowledge is not absolute shit. This is what they used a while back to send Morse codes. Help me. Of course, these radio waves are always available for everyone to pick up and read. That's why when they were sending Morse codes, they would use a special code to encrypt their data so that nobody could understand them. Same thing they do at ExpressVPN. Even when you're at home, which you should be right now, your ISP can see all your internet activity, like the websites you visit, for how long and how much data is transmitted, and can sell this information to advertisement companies. You turn on the ExpressVPN app on your device and bam! The communication from your device to the server of your choice is heavily encrypted, private and secure. This is why I use ExpressVPN. The other reason is that some companies, websites or governments block your access based on your location and content. You know who you are? So I use ExpressVPN to connect to a different country and pull my data from there. The government doesn't know why I connected to, say, Venezuela and don't know what my encrypted data is. And the company thinks, hey, Venezuela is whitelisted, so I get what I need from there. Typical Iranian day-to-day life. Anyway, my link gives you 3 months of free service and then a low monthly fee afterwards. Register and enjoy your privacy, security and access. And thank you for watching.